Good evening, everyone. I warmly welcome you all to this wonderful session, C++ Made Easy with STL. I'm Rajkumar. I'm a second year student in IIT Bangalore. I'm also a part of IETE. I'm joined by my beloved friend Nitesh, who's also with me to explain about C++, to explain about STL and its divisions. I hope you have an informative session together, guys, and also feel free to post your doubts in our chat section. We'll get to you as soon as we can. Thank you.
Thank you for the introduction, Raj. So, welcome to the session. So, we will be learning about what is HTL and what are the components in HTL. We will learn what are its uses and have an hands-on session to show you how we can implement the HTL containers and algorithms. Before getting into the main topic of the session, that is HTL, let us discuss about an interesting domain in computer science. So, can anyone guess what we are going to discuss about? Well, we are going to discuss about competitive programming. So, what is competitive programming? Competitive programming is a mind sport usually held over the internet or local network involving participants trying to solve the problem according to the given constraint. The results will be evaluated on the number of questions solved, the time spent solving the question, and other factors. A problem can have many methods to reach the solution, but competitive programming involves finding the optimal method to reach the solution. Cool. So let me explain this with a simple example. Consider you need to calculate the sum of first n natural number. How will you do it? Can anyone explain it? How will you calculate the sum of first n natural number? You can just unmute and explain.
Using a for loop from
N
0 to
time.
10.
Cool. That's a correct answer. Any other way? I see Garvav's answered that we can use the formula n into n plus 1 by 2. So basically, we can find the sum of first and natural number in two ways. First, using a for loop and iterating throughout the numbers and finding the total sum. Or we can just use the formula sum is equal to n into n plus 1 by 2. And you obviously will know that using the second method, that is using the formula, is the optimal method to reach the solution. And competitive programming is all about finding the optimal solution. Now we have seen what is competitive programming. Let us discuss why should we go for competitive programming. So it makes you a desirable candidate to major companies. So how many of you here would like have a dream of getting a job in the FANG companies? You can type yes in the chat. Like how many of you want to get into Google or Google, Amazon, Facebook, the top companies? I can see a lot of yes. So if you have an aim to get into these companies, then you should know about the international competitions such as ACM, ICPC, Google Kickstart, etc. These are considered as the Olympia for competitive programmers. If you perform well in this competition, you can surely attract the recruiters from the leading firms like Google, Amazon, Facebook, etc. It will help you a lot in your placement. In placement you will be having aptitude round in the aptitude round first, then you will have coding round, and depending upon the company you will have the number of coding rounds will vary. Practicing competitive programming will really help you a lot in cracking the coding interviews and cracking a good placement. It will make you faster and more focused. You will solve a lot of problems as a competitive programmer. You will your brain will be explore you will explore different avenues of your brain, and you can solve any question faster, and also solving lot of problems will help you to increase the focus. You will always be questioning yourself that how can I solve this problem better, how can I solve this problem. So this will make you bet- this will make you better in the competitive programming. Then it will, and the most important part of competitive programming is it will teach you the art of problem solving. As a competitive programmer, you will solve a lot of problems of various difficulties. You will develop you will develop an habit of analyzing and finding the pattern or logic behind every single problem. This will help you to solve the complicated problem in any situation. It will teach you how to work in teams. This is an important skill as you will be working in teams throughout the life. Competitive programming is not only limited to individual sport. There are also a lot of team competitions. You will participate in a lot of teams competitions and learn how to effectively work together. And finally, it's fun. You will have a lot of fun participating in numerous contests, solving problems, and challenging yourself every single time. Is my slide working fine? Like, can you?
Yes, yes.
Yeah,
Sorry, Nitesh.
it's working fine or not
Which
for
slide are you
everyone?
on right now? I
Yeah,
don't
we can
think
see.
it
Yeah,
is.
like I'm on the STL, the duck one,
Yeah,
having the image
Yeah,
with duck.
yeah,
Yeah,
yeah.
Yeah,
okay.
we can see it.
Okay, cool. So when I heard the word STL for the first time, I was like this duck, wondering what is STL and asking everyone. So anyone over here knows what is STL or worked with STL? You can unmute or type in comment. Yes. Okay, so even if you don't know what is STL, you don't need to worry about it. We have got you covered. We will explain what exactly STL is and will be teaching how to use them. Cool. So the main question of the session, what is STL? STL stands for Standard Template Library. It basically provides you an efficient way to store the data and do manipulation in the stored data. The main idea of STL is generic programming. Before I explain generic programming, I want to know that what do you understand by the meaning of the word general? Anyone? What do you mean by the word general? Yeah, you can just unmute and say. Okay, so general means having something. General means something common. So generic programming is implementation of algorithms or data structures, which is common to all the types of data being handled. That is what generic programming is. Now we look into the major components of STL. We have four major components, and they are containers, algorithms, iterators, and function. We'll be discussing about containers, algorithms, and iterators in this session. And before discussing the each component, let us see why should we use STL. The reason we should use STL is it is very easy to use and it will provide a fast, efficient, and robust code. STL has a very detailed documentation and you can easily refer and use any part of the STL without any hassle. It will make your code very short and increase the speed of coding. In competitive programming, the speed is the thing which matters the most. You need to solve the problem fast and be high in the ranking. And uh, high in the ranking. Also, STL provides you numerous containers and algorithms which are useful in competitive programming. For example, you can easily define a linked list in a single statement by using a list container library in STL. And if you have learned data structures and algorithm before, you may know that how big and painful process it is to create a linked list. But with STL, you can do it in a single line. The classes and functions we use in STL are already well tested, and hence they are reusable and reliable. Because of STL, we do not have to define our own sort function or search function every time we make a new program, or define the same function twice or thrice for different data types. Instead, we just use the generic containers and algorithms. Moving on. So before seeing what are STL containers, can anyone say why do we use a container in real life?
To store something?
Yeah, exactly. We use a container to store something. Similarly, in STL, we use a container to store the data and organize and manage the data. That's what STL containers do. And as I said earlier, the main idea of STL is generic programming. So the containers are also generic. They can hold elements of any data type. For example, you can create a dynamic array called vectors, which can store integer data type or float, or even it can store vector or vectors also. Let us look into the types of containers. So STL offers us four types of containers. They are sequential containers, container adapters, associative containers, and unordered associative containers. So what are sequential containers? They implement data structures which can be accessed in a sequential or linear manner, which means that they are arranged in a linear manner and you can access them linearly. And their examples are arrays, vectors, list. And what are container adapters? Container adapters are sequential containers but provide different interface for sequential access. Now, what do I mean by different interface? Let me explain you with an example. You can see the left picture, right? So my mom sends me to supermarket quite often, and whenever you go to supermarket, you can see something like this. So what can you interpret with this? Like how can you take the basket from this structure? How will you take the basket from here? Anyone?
One after other.
One after other, and you can take it only from the top, right? So a
Yeah.
stack is something, yeah, cool. So in stack, you can take the elements, insert and delete the element only from one end, and you can take only from top. You can't take from middle or bottom. It is what exactly stack is, and the interface for this is the last in first out is the interface of stack. You can even imagine a stack of points also. Moving on to next container adapter queue. Now consider a single lane tunnel with single lane one-way tunnel where overtaking is prohibited. So what will happen whenever the vehicle which is entering the tunnel first will exit out of the tunnel first, right? So it follows first in first out interface, and that is what queue is. And for priority queue, you can imagine the same example of single lane, single way tunnel. But what will happen if an ambulance comes? Obviously, all the vehicles will make way so that the ambulance goes first, right? So that is what priority queue is. Higher priority element will be given preference and they will exit the queue first. Now we will see what are associative containers. They are used to implement sorted data structures that can be quickly searched. And you can say that in the name they have the word associative. So they are associated with each other, and they are they have been uh, and they will be as some key value pairs in the memory. You can identify the value using the key, and the example for them are set and maps. Unordered associative containers are similar to associative containers, but they aren't sorted. They will be in an unsorted manner, and examples are unsorted set and unsorted map. Now we have seen containers. Let us move to algorithms. So STL provides different types of algorithm, and they are generic so that you can use on any type of container with the help of iterators. We will be looking what is iterator in the upcoming slides. Thus now we don't have to define a complex algorithm. Instead, we will just use the built-in function and implement the algorithm in a single line. In competitive programming context, you will often need to sort the element, find the maximum element, minimum element, upper bound, lower bound, etc. This algorithm library will really help you a lot as it is already predefined and can be implemented in a single line. Now you might be thinking that I'm bragging about STL, so I will show a meme and you will understand why competitive programmers like STL a lot. So this is a sorting function called bubble sort. It is one of the slowest sorting function. Whereas this is the sorting function defined in STL library, and it is way faster compared to the bubble sort. Also, you need to define it 2-3 times if you have to use for other data types. It will only sort integer data. Now, if you want to define sort float data, then you have to use it again and again. Whereas in sort, it is generic. That is the main area of STL. You can sort any data structures using this single line of function. Now, moving on to iterators. Basically, an iterator will point to the memory address of the STL container classes. And if you have learned C, then you can relate them with pointer. We use iterators to move through the elements of the containers. Without iterators, we can't actually manipulate or we can connect the algorithms with containers. Iterators acts as a bridge between the containers and algorithms and allows us to do the manipulation of the data stored in the containers. There are 5 types of iterators. They are input, output, forward, bidirectional, and random access iterator. So what is input iterator? They are the weakest of all iterators and have limited functionality. It is used to access the element from the container but does not modify the value of the container. It is a read-only iterator. So you can infer for output iterator, you can say that it can only modify the value, but it cannot read the value. They are write-only iterators. Output iterators are like write-only iterators. And forward iterators. So forward iterators contain the features of both input and output iterator, but they can move only in one direction, and that only in one direction, that is forward direction, and that too only one step at a time. Now bidirectional iterator. I have explained you input, output, and forward iterator. What do you guess? Like what will be bidirectional iterator? Anyone can unmute and say. What will be bidirectional iterator?
It can go in both directions. I mean,
Yeah, exactly. Fantastic. Like uh, like bidirectional operators have all the features of forward iterator, along with the fact that they will overcome the limited drawback of forward iterator. They can move in both direction, that is forward and backward direction. And the final iterator, that is random access iterator. It is the most powerful iterator. They are not only limited to moving sequentially, but it also allows random access. They have all the features of the iterators mentioned before. To understand the hierarchy of the iterator, you can refer to the image here. Now we will see an important container in C++, that is vector. So basically C++ vectors are sequential containers that can store elements. These C++ vectors have an ability to grow or shrink whenever an element is inserted or deleted respectively. This makes them more useful than the fixed state static arrays. So also vector elements are placed in a contiguous storage so that they can be accessed and traversed using iterators. Now we look into what are set. So basically set is an associative container in which every element will be unique because we need to have a unique key so that we can identify the value, and set both the key and value are same. Also, it is an ordered container. But what do we mean by ordered container? It will be always sorted after every insertion and deletion operation, and it is immutable. So the value of element cannot be modified once it is added to the set, though it is possible to remove and add the modified value to that element. Okay, so far we have learned what is STL and reusers and learned what are vectors and set. Now let us implement what we have learned. Let's start coding. So I will stop sharing my screen and I will share my code editor. Hold on a second. I hope my screen is visible.
It's visible.
Okay, so I will zoom in so that you can see it well. Also, I will be using the extension name called Competitive Programming Helper. Programming Helper. You can download this extension in VS Code and code along with me. Okay, let's get started. So, so we are going to create a vector first. So to create the vector, the syntax is we have to write the keyword vector, data type within angular brackets, and the name of the vector we are going to create. Let me say I'm going to create a vector of integer data type, and I'm going to name it as x. So what this line of code does is it will create an empty vector. And also you can see that I'm getting an error saying that identify vectors undefined because the keyword vector is being defined in the library called vector library. You have to include hashtag include vector, then you can see that the error will go away. Hold on a second. Yeah, it's fine now. So basically it will create an empty vector. How will you say something is empty? Depending upon the size. So you will say you will say something is empty when the size of the element is 0. So let us print the size and verify whether it's empty or not. So size function is used to find the size of the container. Since it's an empty vector, I expect the output should be 0. Let us verify it. Okay, I have given input here. So the expected output is 0. You can see that the expected output and received output is same. So we have created an empty vector. We can also create a vector of initial size n and initialize to a value k. So let me say I'm going to create a vector named y and let the size be 5. Can anyone say any random number? Anything?
7.
7. So what this line of code will do is it will create a vector named y of size 5 with all the elements initialized to the value 7. So let us try to print the vector. So I will be iterating to the vector using the for loop y dot size I plus plus, and then I have to name the type of the data, and I will print the elements in the vector separated by comma, separated by space. Now you can see that I have used index operator to print to access the element of the vector. You can do this in vector because it supports random iterator, whereas you can't simply print the element using index operator in set or maps because they don't support random iterator. They support till bidirectional iterator. Okay, so we have created a vector of size 5 with all the elements initialized to 0. Let us check whether we have created or not. You can see that I get after printing the vector, I get the output of 5 sevens separated by space. Okay, now I am going to insert. Now I am going to we have created a vector of size n, and also we have initialized the value to the vector. Now let us as the main feature of vectors is it is dynamic. You can insert and delete at any time. So we can use pushback function to insert and value at the end of the vector. The syntax is pushback, and inside the value you need to insert. So I'm going to insert some. Let me name the vector as v for my convenience. So I'm going to insert five different values. Save some 5 random values. Anything.
1, 2, 3, 4, 5.
1, 2, 3, 4, 5. Okay, so we have inserted 5 elements in the vector, right? Sorry, pushback. And back. So I have inserted 5 elements. So, and this will be added to the end of the vector. So the expected output will be 5 sevens followed by 1, 2, 3, 4 and 5. And to print the vector, now I will teach another approach to print the vector. That is, now we are going to print the vector using iterator. We will traverse the vector using iterators. Okay. So I'm going to create an iterator of iterator named IT. You can give any name. Now you can see that I'm getting an error because I have to mention for what I'm creating an iterator. So I'm creating an iterator for vector which has integer data type. So I will write vector integer and then I will use scope resolution operator to define it. Now an iterator for the vector has been created. Now we will try to iterate through the vector. I will use it is equal to v dot begin, it not equal to v dot end, and it plus plus. I'll be explaining what this begin end is soon, so don't worry. So basically iterator points to the address of the element. You can't simply print the iterator using CO statement. You will get an error. In fact, so that we have to use a dereferencing operator that is asterisk symbol. So what this does is it will print the value present in that address. Now I will explain what is begin and what is end. So what this begin function does is it will return an iterator pointing to the first element of the vector, first element of the container, not only vector, any container. And what end will do is it will return an iterator pointing to the next element after the end of the container. You can say that the first element which is outside the container. Okay, so let me print the vector. You can see that we have inserted 1, 2, 3, 4, 5 at the end of the 5 sevens we have created. Now I will be using this 5 lines of code again and again to print every single time I make an operation print the vector. So instead I will make a function so that we don't need to write those 4 lines of code again and again. I'm going to create a function called print vector. It will have vector int and it will have a vector as an argument, and let us copy paste these 4 lines of code over there. And also it's a good programming practice to keep your code modular and make it as a function whenever you use same lines of code again and again instead of copy paste, instead of writing this code again and again. Now we have seen how to insert an element at the end. Also there's since vector is dynamic, you can also remove the elements from the vector whenever you want. So to remove an element that is present at the last position, we use pushback function, and the syntax is the vector name dot pushback. So I'm going to remove the last element of the vector. So can anyone guess what the output will be? I'm going to remove the last element. So basically 5 will be removed because it is the last element. Let us print the vector and verify it. You can see that 5 has been removed. Let me comment the statement out so that the output screen doesn't look clumsy. This is the vector we have finally. And one more thing about vectors, you have the feature of not only inserting the elements only at the end, you can even insert at any position you want. So we will be using a function called insert function, and we'll be passing the position at where we have to insert and the value we are going to insert. And the position should be an iterator because STL is generic and we will be using iterator to implement any functions. So let me say I want to insert an element at the second index. So I'm using v.begin plus from v.begin I have to go 2 steps ahead. So I'm inserting a second index, and can anyone say any value?
9.
Okay. Thank you. I'm going to insert 9 at the second index. And I will print the vector. So in computer science, in C++, we have the indexing will start from 0. So the second index will be 0, 1, 2. We will insert 9 over this position. We will verify by, let us verify whether we are inserting 9 as second position or not. Left one 7. Okay, so 9 will be inserted in second position. Let us verify it. You can see that 9 has been inserted in the second position. So I will comment this statement and remove this one. We have inserted an element to the vector at the position we want. Also, we can remove an element at the position where. Also, we can similarly remove an element at any position. And for that, we use erase function. And for in the parameters, you will be passing the position. So let me say I want to insert the element that is this 7. So with this which is 0, 1, 2, 3, 4, 5, which is a fifth position. So I am going to delete the element that is present in the fifth position. So basically this function will remove the element which is present at the position which is present at the index 5. Let me print the vector now and verify it. So we have removed the 7 at the fifth position, right? And let us verify it. You can see that the 7 at the fifth position is removed. Now we have seen how to insert, delete, and insert and delete at any position in a vector. Now we will see how to manipulate the data present in the container. So the first function I will be explaining is max element. If you have used Python, you might know that there's a function called max, which will return the maximum element present in the list or list tuple or anything. Similarly, the max element will return the maximum value present in that container. And in the argument, you have to pass the starting range and the ending range. So I am going to find the max element in the entire container. So I am using v.begin and v.end. And again, you can see that the max element is unidentified because I am using this function which is defined in algorithm library. You see that the error will clear up now. So this will return an iterator pointing to the first element of this will return an iterator pointing to the maximum element that is present in the entire vector. Again, you can see that I'm getting an error saying that no operator matches because it's returning an iterator and we can't print the iterator as it is. We have to use the dereferencing operator to print the value present in the iterator. So what is the maximum value in this vector? Can anyone say?
9.
So this line of statement should return the maximum value. Okay, so let us see. And you can see that it returns the maximum value in the vector. And you can not only use this function to find the maximum element in the entire vector, but also in the subset of the vector. That is, let me say I want to find the maximum element in the last 3 elements. So if you want to iterate from the end, you will use a function called r.begin and r.end will point to the first element of the vector. So I want to find the maximum element that is present in the last 4. That is present in the last 4 index. So I'm using r.begin and r.end. So what is the maximum element which is present here in the last 4 elements of the vector? Anyone?
4.
Is 4. Cool. Okay, I haven't printed a new line. I'll print a new line here. As you said, we are getting 4 as the answer. Now I will comment this statement out. Similarly, we will use min element function to find the minimum element present throughout the, and I'm going to find the minimum element present in the throughout the vector. So what I have to give in the second argument? Anyone? V dot begin and V dot.
And
That's great. Thank you. So so this will find the minimum element present in the entire vector, and the minimum element present is 1. So let us verify it. And you can see that I'm getting 1. It works fine. Now we can also reverse the vector using the function reverse function, and we have to pass the argument till where we want to reverse the vector. Let me say I want to reverse the vector first the position of the vector. So I will type v dot begin plus anyone for first 3 elements. So we can type 3. So this will reverse the first 3 elements of the vectors. Let us print the vector after reversing. And I will comment this one now. So after reversing the first 3 elements, my expected output will be 9, 7, 7, followed by 4, 2 sevens, and then 1, 2, 3, 4. Let us verify it. You can see that we have reversed the first 3 elements of the vector using the reverse function and mentioning the range of the reverse function. If you want to reverse the entire vector, you can use v dot n to reverse the entire vector. Now we will see how to sort the vector. We'll be using, I'm going to sort the entire vector, so I'm using v dot begin and v dot end. So I'm sorting the entire vector, and I will print the vector now. So what is the expected output now after sorting this vector? Anyone? So after sorting this vector, you will have 1, 2, 3, and it will be sorted in ascending order. 4, 7, and 9. Let us verify it. You can see that I have sorted the vector in ascending order. Statement out. Now, before telling about lower bound or upper bound, I will write the syntax of how we can use lower bound and upper bound. So the syntax is lower bound, first iterator, last iterator, and the value for which you are finding the lower bound. So what this function does is, it will return an iterator pointing to the first occurrence which is greater than or equal to the value we have given in the lower bound function. So, since it is returning an iterator, let me create an iterator to store the value returned by the lower bound function. I am creating 2 iterators, lower and upper, and lower will store the lower bound of v dot. So I am going to find the lower bound in lower bound and upper bound in the entire function, and the value of 7. Hold on a second. Creating a vector low and up. Okay, so sorry, I haven't mentioned I'm creating an iterator. That's why I was getting an error. So I'm creating 2 iterators, lower and upper. So this will return return an iterator pointing to the first element which is greater than or equal to 7. So let us print the lower bound of 7 in the element. I'm going to print the index of the lower bound. So in minus v dot begin. Now you might ask that why I'm using v dot begin, subtracting v dot begin. So this lower bound will return some any address with address, but it will return the absolute address. So it will be a huge number, and you can't really know what it is returning. Instead, if you use and we are separating with v dot begin so that it will return the relative address. So the addressing will start from 0, 1, 2, 3. It will return from 0, 1, 2, 3. That's why we are using v dot begin. So the first element that is greater or equal to 7 is this 7, and it is present at the position 0, index 0, 1, 2, 3, and 4. Let us verify it. So you can see that I'm getting the lower bound. Similarly, we will discuss about upper bound. So what upper bound does is it returns an element which is greater than or equal, which is strictly greater than the value we give in the function over here. So it will return an iterator pointing to the element that is strictly greater than 7 in the vector. So let us print the upper bound, upper minus v dot begin. So the element which is strictly greater than 7 is present at the index 0, 1, 2, 3, 4, 5, 6, 7, and 8. So it should give 8 as the output, and let us verify it. So we have cleared, we have found the upper bound, lower bound, etc. Now we have seen the basic operations which you will need in vectors. Now we'll move on to sets. So similarly for vector, for creating a set similar to vector, we have to say set the data type we are using and the name of the set, and for that you have to include the library. So I'm using I have to include set library to use the set operation, and you might wonder that you need to include lot of you need to remember lot of headers file so that you can use all the functions. Instead, but we don't need to do that. Instead, we can just include a single header file called bits series C++. It will contain all the header files which you will be needing in computational programming or basically any programming. So now, to insert a value into set, we will use a function called insert, and we'll just insert function to insert values into the set. Can anyone say any 6 numbers so that I can insert into the set?
525,
525,
132,
132,
21, and 1.
21, 1, and let me insert 12. So I have inserted these values, and like similar to vector, we'll create a function for printing the elements in the set. And it will have set as an argument. And I'm creating a set iterator so that I can iterate to the set. There's also another way to iterate to each element in the set, and Rajkumar will be explaining how we can do that. So I'm creating an iterator, IT. So I'm going to iterate to the entire set. So I'm using begin and end function. IT is not equal to x.end and IT plus plus. Let us print the element in the vector. Okay, so instead of semicolon, I have used comma. Yeah. So can anyone say what will be the output of this? Like how the elements will be inserted in the vector? I covered an important point while saying about vectors, about set. Like what will be how will this set be printed now after inserting these values?
It will be printed in sorted order.
Great, you're correct. So set is a sorted data structure. After every insertion, it will be printed in a sorted order. So we'll have 1, 25, 12, 1, 12, 1, 5, 12, 25, then sorry, 21, then 25, then 135. Let us verify it. Okay, I have inserted 132, but I gave 135 here. So you can see that we're getting a set, and that is inserted in sorted order. Now I'm going to insert, let me say 1 and 12 again. So what will be the output now? I'm inserting 1 and 12 again into the set. So what will be the output?
It will be the same.
Exactly, because I have said earlier that set contains only unique items. It won't contain any duplicate items. Even if you add 1 and 12 100 times, you will get the same output because it contains only unique items. And you can see that we get the same output again. I'm going to comment this one and remove this. Now we have seen how to insert an element into the set. We will see how, and also not only single value, we can also insert array of value into the set, like sequence of value into the set. So I'm going to insert, let me say 28, 5, 6, 5 is already there, so okay, 10, 11, 22, 32. So to insert a sequence of value, we will use s.insert, the set name dot insert, the sequence container name followed by sequence container name plus the size of the container. So here the size of the container is 5, and let me print the set after inserting, print s. So I am inserting 5 values, and again it will be sorted. So I am inserting 1, 5, 10, 11, 12, 21, then 22, followed by 32, and 28, 32, and then 132, 25. So let us print the set. You can see that we have inserted a sequence of value into the set now. And there's also a function called count function, which will count the number of occurrences present in a container. And as I said that set contains only unique value. The count function will return only 0 or 1 for a will return only 0 or 1 as the output. So okay, so I'm going to check whether if an element 32 is present or not. Since 32 is present, we'll see. I'm going to print the. Since 32 is present, it will return 1. Let us check it. You can see that 1 is printed now. And what will happen if if that element is not present in the set? So let me say I want to find I want to take the count of 99. Since the element is not present, it will return 0. Let us check it. You can see that it returns 0. And you can also use upper bound and lower bound similar to the way we have used for vectors. Now I will explain a function called swap function. So I'm going to create another set called s2, and it will contain, let me say, 5, 9, 12, and 25. So I will just clear this one. So I'm going to print the first set and print the second set. I will comment the statement out. So now the first set will be printed, followed by the second set, which contains 5, 9, 12, 25. Now I'm I'm going to swap both the sets. So say swap after swapping, giving two new lines, and let us print the set. So to swap the vector, we have to write the first vector name followed by swap, and the second set we are going to swap. So this will swap. Now the content in S1 S will be swapped to S2, and the content in S2 will be swapped to S. Let us print the set after swapping. I'm not changing the order. I'm printing as exactly as this. 5, 9, 5. So let us see what will happen after swapping. You can see that after swapping, wait a minute. So you can see that before swapping, the set S contains these values, and the set S1 contains this, S2 contains these values. But after swapping, you can see that I am printing S, but I am getting the value of S2 because we have swapped the set now. And finally, we can use and that's it. And that's it from my side, guys. If you have any doubt, please stay till the end. We'll have a doubt clearing session. Now, I would like to hand over this session to Rajkumar, who will be explaining about an interesting topics on maps and pairs. See you. Thank you. And over to you, Rajkumar.
Thank you, Nitesh. I'll share my screen. Is my screen visible?
Yes.
All right. Okay. So thank you for the amazing session. It was really wonderful from your side. Even I learned a thing or two from your session. Okay, so Nitesh said a lot of things about a lot of things. So why don't we just step back and do a little recap? First we saw what exactly is competitive programming and how it's going to help you in your developer career and how fun it is. And then we saw about why you should go for competitive programming. And then we saw about Nitish's story regarding his introduction to Stl. And then we talked about Stl, and then we talked about how Stl is divided. Stl is divided into containers, algorithms, iterators, and functors. Now, we really didn't explain about functions a bit, so I highly recommend you to go and check it out. It's really interesting. And then we saw why we should use Stl and how it helps us in our coding experience. And then we saw containers, he explained containers, and then we saw vectors, we saw sets, we saw algorithms. And now I'm going to explain to you something interesting. I'm going to explain to you about pairs and map. Now, when we started to take notes for this session, me and Nitesh, we decided to separate the containers into two. Nitesh will take contiguous containers, whereas I would take something else. I would take some two containers that are deeply related to each other. Those two containers are pairs and map. Okay, so how it is deeply connected, you might ask. Map, I'm going to spoil it right now. Map executes pair. Okay, so map uses pair to work. So that's how they are related to each other. Now, you might be a bit confused right now, but I'll show you how it's done in our hands-on session. But before talking about pair and before talking about the connection between them, let's talk about pair first. So first, pair and Stl. So when I say the word pair, what exactly comes to your mind? You can open your mic and you can say what exactly do you think right now when I say pair?
Combo.
Oh, that's right. Combo. So what exactly does combo mean? It's a combination. It's a good word. A combination of two things, right? That's what pair means. Okay, so that's why. Two elements combined into one. That's what pair means. Now, this pair need not be just elements. It can be any elements. In fact, you can actually have a pair of pairs also. So let's just see it with a good example. We have something called pair of apples and we have pair of fruits. So here I have an example with two apples, so I can call it pair of apples. Here I have two fruits. I think it's apple and orange, I guess. I forgot. So this is pair of fruits. So you need to really understand one thing. When I say a pair, the two elements inside a pair need not be of the same type. In fact, it can be something different, something dissimilar, such as I'm having two different fruits with me, and I call it a pair. Okay, so where exactly do we come across this pair? Do you have any guesses? Come on, guys, we spent like 3 years studying this. I'm sorry, 5 or 6 years studying this. Okay, I might be a
XY coordinates.
You're right. We are using XY coordinates, right? So X coordinates and Y coordinates. So coordinates, two elements, that's a pair. Not only coordinates, we can also, not only XY coordinates, we can also represent XYZ coordinates, like this. So here we have a two-dimensional coordinate and here we have a three-dimensional coordinate. Unfortunately, in C++, we don't have a container called as trio, which would store three elements. Instead, you can have a pair between a coordinate and another pair. For example, you can pair X and Y together and have a Z integer separate. So you can pair up a pair and an integer. Okay, it is just a pair, right? You might argue with me, it's just a pair. Why do you actually need a container in C++? I can just have two integer variables. I can call it a day, right? Well, you're kind of right. But let's take an example. So let's take a simple problem. Given an array of coordinates, perform some calculations. Now that calculation might be anything. It don't need to be, I'm not going to specify, it can be any calculation. But as an input, you're given an array of coordinates. So one way of solving this problem, one workaround to solve this problem would be to have two vectors. Vector 1 would represent all the X coordinates. Vector 2 would represent all the Y coordinates. Great. But there's a problem. What if there is a condition or a constraint such that if X is going to change, Y is also going to change? Now we have two vectors which are separate entities. Now, if you try to change something on X, it should also be changed on Y, which gets really complicated because whenever you do something with the X vector, you have to make sure to do something with the Y vector. But if you're not going to do that, then the whole code fails. And if you have a 200 line to code, and if you miss the vector, then it's not really, it won't look good, right? Okay, see, two vectors now. How about a vector of pairs? Now, I'll teach you how to actually have a vector of pairs in the upcoming slides, upcoming code along session, but hang tight. See, you can have vector of pairs. See, you can see here I have a vector int A, a vector int B. Now you know what vector is. Nitish just gave this wonderful explanation about vectors. Here you see something different. Vector of pair int, comma int. So I gave you some reasons why we should be using a different separate container for pairs, but there's also something else that we can. There's also not only something else, we can also do a lot of things with pairs, and pairs are really efficient. Now, let's take into consideration why it would be used. First of all, we have this. We can be used with other Stl containers. As you can see, I'm having four different lines. The first line has two integers. The second line has a vector inside the pair. Third line has two pairs. And the fourth line has a vector and a pair inside it. Now, we'll see how it's going to work, but just hold on a minute. Now, if you have some experience with C or C++, you might be knowing something called as structs or classes. Now, if you're new to this, if you're a fresher, you definitely be learning it, and it's almost fun once you really get what I'm trying to say. But structs and classes can be used to mimic this kind of a pair structure. But still, there are things that you can do with a pair that you can't really do with classes or structs. We'll see what it is in the next slide. One, it is optimized. Now, we are talking about C++. Now, C++ is not a competitive coding only language. In fact, it is one of the best languages in the world. It is used to create game engines. It is used to create games. It is used to create machine learning models. For example, if you explore machine learning, If you explore that community, you would come across something called a scikit-learn. Scikit-learn is completely based upon C++. Not only that, it's also used in CERN. So that's that. What am I trying to say here? C++ is heavily optimized, meaning that you don't really need to worry about the complexity. I'm sorry, how long something takes, how much space something takes when you're trying to do. It's heavily optimized, and so that you can actually use it on the go. And also we have inbuilt functions. So as an example, we have par1.swap. This function, same as the one you saw in sets, is used to swap two pairs. Now, if you try to define something similar to pairs inside using structs or C++ classes, you would run into a problem, because if you're trying to copy a class into another class, there's something called a shallow copy, deep copy. So you really get yourself into some trouble. So it's better to use pairs instead of going for C++ classes or C structs. And also finally, it helps us to be organized. You can still define int A, int B. You can still define vector A, vector B, and carry along. But the problem is that after a couple of days, when you go back to your code, you wouldn't really know what is going on in the code. So if you really want a robust, at the same time optimized, at the same time a code that helps you to be organized, better go with pairs. And enough talking. Let's go and let's get our hands dirty. So just what Nitish used, I'm using the same extension. So you can also open your code editors. I highly recommend VS Code because it is a text editor. It's highly versatile. So if you have your own code editor, you can also find online editors. You can open it right now. All right, we'll start coding now. So first of all, we'll include IOStream, just like all times. And now you need to include something called as a utility. This utility is going to contain pairs. You can actually include, I cannot include pair, remember that. I have to include utility. Okay, I'm going to include int main. Okay, so here I'm going to create a pair. So how would you create a pair? You'd say pair int, comma, int, ABC. Now ABC is just a name. Okay, so I'm getting an error right here. Why is that? Because I haven't included something called as using namespace std. Now, this is not a C++ session. We're now going to explain using namespace std. You can really find good tutorials online if you want to. Basically, you just need to include std, because every Stl containers algorithms is defined using something called as standard std. So let me just define that. Namespace std. Now we should go away. Yes, it went away. So how would you input something inside a pair? You have to use something called as a make pair. This make pair is going to create a pair for you. So all you need to do is that you should do ABC is going to be equal to make pair 1, 2. All right, that's how you would create a pair. Okay, we talked about something. We talked about pair of vectors, right? So how would you do it? Let's create two vectors let's create two temporary vectors. So I'll do vector, I'll do int, I'll do temp1. I'll do vector again. Oh, I'm getting some error again. See, this is the problem with including everything one by one. Instead, as Nish pointed out, you can include the bits header file. Now, this bits is nothing. It's nothing but the file that contains like some 30 different header files. Instead of including one by one, you would just include everything together on a single line. So after inserting, you can see the squiggles are gone. So I'm going to create another vector. I'll name it int. It's going to be int vector. I'll name it temp2. I'll define it on the go, 1, 2, 3, 4. And here I'll do 1, 2, 3, 4 again. Okay, I'm going to create a new vector. I'm going to create a new pair that's going to contain vector. So pair, vector, int, comma, vector, int, and I'm going to call it pair vec. Okay, so this pair vec is also going to take two values, and that two values is going to be vectors. Okay, so pair vec is going to be equal to make pair. Sorry, I capitalized it. Here you have to do temp1, temp2, and it works. There are no squiggles here. I'll just put it on 0. Okay, so these are how we would insert something, right? So let's talk about printing something. How would you output something? If you try to output a pair as it is, for example, if I come here and if I would say out ABC, Let's see if it works. And it's showing some squiggles again. It says that we can't really do it. So what we should do at that time? Let's explore more. So we saw make path. We should use path.first and path.second. This path.first is going to point to the first element inside the path. The second will point to the second element inside the path. So let's try it. So instead of doing this, it's very naive. And let's do first, let's give some space and let's do abc.second. And for brevity, I'll do this. Okay. I'll do cout. I have pathvec, right? Dot first. I'll do some space and I'm getting error again. Okay, so why exactly is this error happening? Do we have any guess why exactly this is error happening? I mean, we printed integers, but we can't print this. Why is this happening? You don't need to be correct, guys. It's all normal. All right, I guess I'm going a bit fast. I'm sorry about that. I'll go a bit slow. I'm sorry. I guess. Please, if you're not going to ask any doubts, please mute yourself. All right, so I'll spoil it. If you hover over this, you can see something. You can see a vector. So when I do path.first, I'm going to have a vector. You can't really print a vector, right? I mean, you saw in the tuition section, he never printed a vector as it is. Instead, he used something called as a for loop with an iterators. Now that's too much. That's just so much more. I don't like it. Instead, you can use something called as a for each loop. Now, if you are familiar with other programming languages such as Java or JavaScript, there is something called as a for each loop. It's kind of similar, however, the syntax will differ. So to create a for each loop, all you need to do is to say for. Here you can use a keyword called as auto. This auto keyword is similar to if you have some knowledge about Kotlin, you know there's something called as a var. Now you don't need to know it, but it's kind of like that. This auto keyword accepts anything that you throw at it. So I'll do auto I, and here I'll provide something. I'll provide a container. Now that container should be a vector asset or a map. So I'll provide vec first, and here I'll print it. I'll provide some space and come here. I'll put some new lines for understanding. If I hover over this auto, you can see I'm having a vector and an iterator. So that exactly what auto does. It just determines the necessary data type for you. Okay, so we defined the first thing and we'll do it again. This time we'll print the second vector. So first I'll do second. All right. So let me just run it and let's see what happens. All right. It's taking some time. Okay. First we have 1, 2, and this 1, 2. We printed this 1, 2, and then we had 1, 2, 3, 4, and we printed that here, and then we had another 1, 2, 3, 4. We printed that. All right. So we saw what is first and second. Now let's talk about swap for a minute. Now swap is exactly what Nitish had said in this set session. Let's take a look. So technically we have a vector pair and an integer pair, right? Let's swap this. I'll do abc dot swap. We have the function right here, and I'll do pair vec. Okay. It's showing something. Why is that? You can't really swap two pairs that have dissimilar data type. For instance, ABC has the data type int and int, pair vec has the data type vector and vector. So you can't really do that. So for that, you have to create another pair. Okay, so let me just clear this out. Let me create another pair int comma int. I'll call it pair 2. It's going to be equal to make pair. I'll have some 100 and 200. I'm going to print these two pairs and I'm going to show you how this swap actually does things. I'm going to say abc out abc dot first. I'll give a space to do abc dot second. I'll provide a new line, and then I'll just say pair 2. It's just some shortcuts that you can also Get to know, I guess. Okay, so here I'm going to change this to path2. Okay, and here I'll provide some new lines, and I'm going to say something like changed. Yeah, that's better. And let's try to print it. Let's see what happens. Okay. I guess I'm missing something. Yes, I'm missing something. I'm missing the semicolon. Yeah, it's like it's not JavaScript, unfortunately. As you can see, first 1 and 2 gets printed, which is from ABC, and then 100, 200 gets printed, which is a part of path 2. And we swapped it, and then we got 100, 200, and we got 1, 2. And that's great. And now that's it for path. I mean, now we don't really go into a lot of functions in path. The reason is that time constraint, obviously. You can still go through a lot of different functions in path if you go and check it out online. There are beautiful websites such as Geek for Geeks or C++.com, which I use personally. Okay, so we completed path. So let's talk about something else. Let's talk about maps. Okay, so what exactly is a map? To understand what exactly is a map and to differentiate this map between Google Maps, you need to understand something, and that is mapping. Okay, so mapping. So what do you think mapping is? What comes to your mind when I say the word mapping? You can talk, guys. It's like not a faculty. God, no. Yes? All right, we'll see it. Yes?
Mapping means to connect two things together.
Exactly. Well, it's 1/2 of the definition, but we'll see. So what he said is kind of right. I mean, we are mapping two things together, but there's something missing. Mapping is not only connecting two things together, but you're connecting such that you can refer one thing with another. So that's very important. Now, this definition might be a bit vague, so why don't we take an example about it? Okay, first of all, we're going to consider two things, A and B, where A represents student register number and B represents the student name. You need to understand one thing and you need to pay close attention. I given something called as a key, and I gave something called as a value. What does that mean is that you can refer to a value with a key. That suits our definition, our vague definition about you can refer one thing with another. Okay, let's see an example regarding this. So I have some form of a table here, and this is the key part, this is the value part. You use keys. For example, this student register number does not mean anything, right? Except the fact that it is used to figure out the values. You can't really use S name to do stuff. We have two Adams here. So which Adam is what Adam? We don't know. So we have to use this thing, whereas this register number, student register is going to be the key, and student name is the value. Okay, we saw some example. Okay, awesome, great. But why in STL? Well, let's take a look into it. Okay, let's understand why we need STL, why we need maps in STL. Okay, let's say you're given a string as an input and you have to print its respective integer. For example, let's say in the input I'm going to put O&E, and you have to print the integer 1. Let's say I'm going to give a 5VE, and you need to print integer 5. Now, one way of doing this would be to go the old route to do a workaround. What is that? You know something called as a vector. Think like two vectors. One vector storing strings, and one vector storing integers. Well, it kind of works, I guess, but it's not really. You're not trying to do something with what the question has provided you. You're given a string. You have to print the integer. So what are we mapping here? What are the two things we are mapping here? Is there any guesses? As you can see, we have a string and an integer. Yes, we are mapping a string and an integer, right? Now, you might be stubborn and say, I'm going to use the workaround, I don't care about you. Let's take a look into the next example. You are given a number from 1 to 100, and you're also given an input such as O1E or FIVE, and you are going to print all the numbers in that 100 numbers that are ending with 1. If I give input as FIVE, you have to print all the numbers ending with 5 from that 1 to 100 numbers. Now, how many vectors will you create now? You can't really work around this, but if you try to understand the gist of this question, you are asked to map a string and a vector. So if I produce a string, you have to output a vector, right? Okay, so that's about it. That's enough talking. Let me go back to the text editor and see how it goes. I'll come back to this up next. So let's create a new file. Let's call it maps.cpp. And I will include string. I'm just going to include, you don't really need to include stream if you're including bits, but I'm going to go with the regular stuff for right now, okay? And remember, you need to include namespace, std, int, main. Okay, so here's how we would define a map. Let us say map, and you have to put something, let's say in, and then integer, and let's say you're going to put my map int. This map is going to map an integer and integer. But our question something's different, right? I'm sorry. Our question asks us to map a string and an array. A dynamic array for, I'm just going to say dynamic array because I want to map a string and a vector. So how would you do it? All you need to do is do the same thing. You have to say map, int, sorry, not int, string, and a vector. Now, as you know, we have to define vector. You also need to define string. It's not going to show an error because there might be some libraries that have already included strings, so that's why it's not showing. But it's better to just include bits and just call it a day. Not atomic, obviously. C++ storage. Okay, let me just clear this out. And it should go away. Not I'm dead. And it went away, thank God. My math back. Okay. Okay, so how would you input something? Okay, so here's how we would input something. You have to say my map int. You have to have some. You have to open some brackets, and here you have to provide the key, which is going to be an integer, and here you have to provide the value. Let's say 300. Okay, that's how you would input something. So how would you input a vector? You have to create the vector first. So vector int, let's say my vec, equal to 1, 2, 3, 4. Now I'm actually cheating you. I'm not going to solve you the problem. I'm just going to show you how we can give the output. That's all I'm going to show you. You can try out this problem. It's not that hard. So that's a vector, and I can actually do my map, not int, vec. I can put a string, O1E. I can put my vec. Okay, so let's give an input and let's see what happens. So I'll define a string. I'll define input. I'm going to get the input. I'm going to print it. Okay. So see out my. I'm not going to print the integer. I'm going to print the vector. Now, will this work? I'm asking you guys. Will this work? When I said input, it's going to print out the vector. Okay, so it's going to provide the. It's going to return the vector. But do you have the ability to print a vector? Well, I know I'm going a bit fast. If you know the answer, you can drop it in the chat box. Okay, so you can't print a vector as it is. We actually saw this in the past section itself. So how would you print it? You have to use a for each loop. So you can say for, you can do auto I, and you have to do, and here you have to provide the input. So I'll do my map vec input, and here you're going to find something interesting. Believe me. Okay, I'm going to do cout my, I'm sorry, cout I. Okay, fair enough. Here you can say integer I. Okay, let's try it. Let's try to print it. I'm going to provide some space. Okay. Here's this. So yeah, I'll create a problem. I'll give an input as 1 because we have 1. I'll try to run it. Let's see what happens. And it's giving me some input. It's giving me 1, 2, 3, 4, just like this. All right, fair enough. But what if I give something that does not exist? Will it show an error? Will it show something else? Let's see. Instead of giving 1, I'm going to give you 2. And it says passed, and there's nothing. Okay, it's pretty confusing. Let's try to do something else. Why don't we try it using this? Why don't we try it using my map int, and let's see what happens. So I'm going to clear this out. I'm going to print cout my map int. I'm going to put input, and okay, I'm missing something here. Let's copy it. Okay, I'm getting some errors released right now. Why is that? It's because input is a string, whereas the key is an integer. That's why you're getting that error. If you can't catch that error, don't worry, guys. I mean, it's going to take a while. I mean, I took some months to catch these errors, but you'll get good. Don't worry. Okay, here I'm going to provide some random integers. Let's say 1000. Let's see what happens. And I'm getting 0. So that's what happens if you try to get a map that does not exist. It's going to print 0. It's going to print nothing. Okay, these are this. I'm not going to solve it. Tricked you. Okay, let's have a quick intro about these 3 different maps. Okay, I'm just going to remove this. I'm going to say 3 map. Now, don't get scared. I predefined this. You don't need to worry about it. But I'm going to define. I'm going to tell what are we going to. What does these 3 things mean? What does my map mean? Another map mean? And multi-map mean? Now, you need to have some understanding about data structures to understand it. But let me just give you a quick fact check. Let me just give you a quick intro. My map and another map. I haven't said anything about another map. Don't worry, it's just the same. It has some difference. My map and another map are not that different, except the fact that when you insert something in my map, I'm sorry, just map. When you insert something in map, it's going to be sorted based on the keys. Okay. What about another map? Another map is also kind of different. It's not going to be sorted. It's in fact you can't predict the order in which another map will be. The elements will be stored. The reason is the data structure that's being used is does not care about the order. But what about the spec key multi-map? And what is the spec key insert keyword? This insert keyword is another modulation of this thing using this. The reason is that there is nothing called as brackets inside multi-map. That's why we're using insert keyword. It's literally nothing. You just need to define the values that you want to insert inside the curly braces, and you have to use dot insert. That's literally it. Okay, so let's see the difference right before our eyes. Okay, let's try to print everything. Auto, my map. Now I'm not doing it the same way I did before. Okay, if I just hover my mouse over, I'm seeing something weird. I'm seeing a pair. Why? In the first slide, I said pair and maps are related, right? And I said something like pair are being used by maps to implement. And that's literally it. The maps uses pairs to print stuff. Okay. Now you know for sure that what we use to print pair elements, you have to use dot first and dot second, right? So let me just do cout. I'll do I dot first. I'll do enter space. I'll do I dot second. I'll give some new line for brevity. So I'll just copy it. I'm lazy. And it's getting late. I'll do the same thing here. And let us see all of them together. I'll just do one more thing. I'll just print some new lines so that we can see it in a much clearer fashion. Okay. I'm just gonna do this. Don't worry, it's just shortcuts that you can find it in Google. And then I'm gonna run it. Let's see. Let's hope this works. And this is not gonna work. The reason is that everything is just my map. So I need to change this. I need to change this as my another map. Here I have to change this as multi-map. All right. Let's try to print it. As you can see, I inserted 3 and 100 first, and then I inserted 2 and 200, then I inserted 1 and 300. But if you take a close look, it's printed the opposite way. Why? Because map sorts the data we are inserting it based upon its key value. I inserted 3 to 1 in this order, but it's printing in different order, in a sorted order. If you take another map into consideration, I'm inserting 3 to 1. It's doing something else because another map, like I said, it uses a different data structure called as hash tables. You can Google it. Due to that, it's not going to print everything in order. What about this guy, multimap? So this multimap is special because it allows duplicates. Now, what do I mean by that? Let me just copy it. Okay. Here, I will just change 3000 to 30,000. Okay. I said earlier that map and another map does not allow duplicates. What do I mean by that? When I give a duplicate value, that duplicate value will be replaced. Okay, so I just did this and this. Let me just print it. Let's see what happens. As usual, I got sorted, but you need to understand one thing. It's 130,000, it's 130,000. Here, I'm inserting duplicate elements, and it's printing duplicate elements. Why? Because multimap allows duplicate elements. And also you can see I'm inserting in a different order, it's getting printed in a different order. So that's the difference between these three things. Okay, I'll finish this quick, don't worry. And then we have map.count. Let me just print it quickly. Map.count is just counting the number of keys. Okay, that's it. My map.count. If you take close attention to this section, it's just the same thing. Here I'll provide 1, and here I'll just give a line. I'll just remove this, and I'll do the same thing here, but with multimap. Okay, I'll do cout. I'll do multimap.count, and here I'll provide 1. Okay, let me print it. As you can see, I'm getting 1 here because even though I'm inserting it twice, I'm getting 1 because there are no duplicates in map. Whereas here I'm getting 3 because I'm inserting 3 ones. Multimap allows duplicates. Okay, we saw count. We can see find. So this find also differs a bit. It really goes and finds something, and it's going to return the iterator having that. Okay. It's not that hard. You can actually use it yourself. You just need to say .find and key. Now this key should contain the key. Okay. For instance, if I do cout my map.find, I'll do 1, and I'll do new line, and it's showing some errors quickly. Okay. If you pay close attention to this section, we can't really do this again because it's going to return an iterator. We can't print an iterator. So what we should do? We should use star, and I'm pretty sure it's going to work. Okay. It's not working still. Why? Because inside maps iterator, we have something called as a pair. And you know very well we can't print a pair. So what we should do? Well, you just need to create, you just need to put some brackets, and you will print pairs like old times. You do first, and as quickly as should be gone. Let's see. I'll provide some line, I'll provide some space. I'll do star my map.find. I'll do 1, I'll do second. And I think that's about it. Now, if you're coding, don't do this. The reason is that I'm trying to find the same element twice, which is really not ideal. The reason is that, okay, it's just 3 elements, man. It's not going to be a big deal. But if you have around 1 million elements, it's going to cost you some time. Okay, I'm just going to run it. And I'm getting the vector. I'm getting the iterator. I just dereferenced it. I'm getting the answer. You do the same thing with another map and also with multimap. And just like you did with pairs, you can swap to maps. But you need to understand one thing. We can't really swap to maps that have dissimilar data types. If you want to swap map 1, map 2, then map 1, map 2 should have the same key value data type. And here we have clear. This clear is just a clearance function. Now, it's really become helpful when you're developing something with C++ because you can let other people know you cleared the map. Nothing happens if you clear a map. I mean, let me just print it again. let me do my map. I'll do my map.clear. Okay. I'll do for auto I. I'll do my map, and I'll try to print it. C out I. Don't take that capital I into consideration. It still says it's a pair. Let me try to print it. Let's see what happens. Because the reason is that we haven't executed it yet, so that's why. So you have to do the same. So I don't want to do that. Okay, let me just do it. Why not? Okay. So we have to provide this. Okay, here's I. Got it. I dot first, I'll provide a space. I dot second, I'll give a line, and let's see how it goes. I'm not gonna print anything else. Let's see. It says pass, and it prints nothing. That's what clear does. Clear just clears out the map. Okay, we saw what is a clear, what is clear, and we came to a conclusion, guys. It was I know I rushed a bit at the end. I'm really sorry about that. I just don't want to take your time. It's the weekends, and it's been a tough week for you guys. So that's about it. Thank you ISTE, and thank you VIT for IETE and VIT for giving me this wonderful opportunity. And I also thank on behalf of Nitish. It was really a wonderful session with you guys. You are cooperative for the most part, and I'm thankful for that. And if you have any doubts, you can stay. You can ask doubts. I know it's a lot. There's a lot of things going on. And don't worry if you really don't understand something here. You don't need to worry about it. I mean, I took like 2 or 3 months to understand stuff. You can go onto internet if you want to know something. You can actually go to internet and type what's this, what's that. It will just provide you. And the best two, I would say, the best two links that you can use, websites that you can use is c++.com and also Geeks for Geeks. Both are pretty good in my opinion. I use them both personally. If you want to practice competitive coding questions, you have a ton of websites out there. We have HackerRank, you might have heard about it. We also have something called as CodeChef. We have Code Forces. We have Top Coder, Hard Coder, Lead Code. So there are a lot of resources. All that resources require is a person who's as enthusiastic as you. So if you have doubts, guys, you can stay here. You can also follow IETE in our. You can connect with IETE. You can follow IETE. You can also like us on Facebook also. And if you had any doubts, you can stay with us. If you don't have any doubts, well, it's been fun. Thank you guys and have a great weekend.